Hi all, welcome to Balkan Shipyards. So March 21 and we started, we're building. Here's the build. This is the armor, 22-foot armor, 6.7 meter long. It's for the HAVAYA 30-25 because the HAVAYA 30 has turned into a 25, so she's a HAVAYA 30-25, and that's so she's 7.50 m and a 6.7 meter armor. I really like it. There's old make or break upstairs, and he's the base of the stuff, and he's what we learned and what we understood, and we will roughly work in the same way. So this is how I like personally to do armors. I've found this to work nice. This is almost, I mean, there's a 4-meter armor, that's make or breaks armor. It's got some of these characteristics in it and it works well, so I've enhanced stuff over here and I've gone to this. So basically it's a V hull up to here, and then there's a flat bottom so it can accept a dagger, and then it's a V hull again. So I always like rake on bows. It helps, it guides the bow up the wave. And then I like it when it builds flare. I like it building a lot of flare pretty soon. So then the volume brings you up again. Then I like a little bit, okay, so I've used less rocker in the past. I've used more rocker on crystal clear, and then later on I've used less rocker. Now I'm back to a little bit more rocker. Rocker again helps you up. Hi all. Winter in the Balkans, so we're focusing on boat design and trying to stay indoors. So here's the HAVAYA 30. So now she's going to be a HAVAYA 30, but she's going to be only 25 foot. So she's going to be a HAVAYA 30, 25 foot. Meaning I've downsized the boat to 3 sheets of ply, which is 25 foot, 24 salmon. I've done this for 2 reasons. I want to cut costs, I want to cut build time, and this doesn't fit in my workshop so easy. This is just a little bit too big for my workshop, and that's a heavy displacement 24 cruiser. I believe I can take all I need inside it. I've got about 800-900 liters of displacement to waterline on this hull. It's much wider than this one, but then again it's much narrower than make or break was a 1:7. Now 1:7 would be a ratio of a Milan. A good old Milan, the Vaca would be about 1:7. So that was why make or break, my last pro. Over here we'll 1:14 waterline on the HAVAYA 30, and on the HAVAYA 30-25 we're going to be about 1:10 waterline. Okay, I'm happy with 1:10. I mean I wish I could go narrower, but then I'm losing displacement, so I don't like that. Now the way I design boats, this video is going to be about that. So the way I design a hull is, I start off with my requirements. How much am I going to load that hull and how much is it going to weigh? Once I do that, so let's say my requirements of a cruising Vaca would be minimum 700-800 kilos. 900 a little bit better, but 700-800 is enough for me. Let's say 800. This hull's got over 800 to waterline. That's why it's a 1:10. That's why it's wider than the HAVAYA 30, which is a 1:14. She can take a ton. He can take almost a ton, and he's a HAVAYA 30-25. So before I build my cardboard models, I will roughly know the sizes and the volumes I need, because I will do this. This is a quick calculation that will tell me how much weight this armor will have to carry, including itself, and what the volume it will have to have at waterline. So I'll just go like this, and I'll say, I mean, I'll draw out the whole boat, roughly to scale, doesn't have to be very perfect. And I'll start calculating the weights that are coming onto this armor. So I've got over here decking. I've come to the weight of my decking. I've calculated everything. I know the weights of the materials, and I know how big it's going to be and stuff. 70 kilos of decking divided by 2 is 35 kilos is coming onto the armor, because half the deck is going onto the vaka, the weight of the decking. Then I'll say the armor itself, I'll calculate the plywood, the amount of plywood, and I'll know, and I'll figure out its weight, and I'll calculate the weight of the dagger board, and I'll find all the weights over here involved, and I'll come out with 70 kilos. Then I'll take the akkers. I've calculated the weight of my akkers. I know how big they're going to be and stuff. So I come out with 3 akkers, 70 kilos. That again I will divide by 2 and come to 35, because only half of the weight of the akkers is onto the armor. Then I'll put crew and gear, because I might have some anchors over here, boxes with anchors and stuff. So the two of us, me and Zhenya, will 120 kilos. So let's say I'm allowing for another 30 kilos of gear that will be here in this area of the boat. But because this is not in the middle, it's closer to the vaka, this weight, which is 150 kilos, I'm going to divide it by 3, and I'll come out with 50 kilos. And there you have it. So it's 35 plus 70 plus 35 plus 50 comes out to 190 kilos. I know that this armor at waterline must have 190 liters of displacement. Now, once I've built the armor, I can measure and make sure it's there, and if it's not there, I'll make it again. So this armor is there, and I'll show you how I calculate volume now. Okay, so let's calculate the volume of this armor at waterline and see what we have. So this is what I love about Proas, they're symmetrical. So these two compartments are identical, and then that bow and that bow are identical. Okay, so let's start off with these guys, the easy ones. So over here it's narrow, over here it's wide, this compartment. So I'll work on the middle. I want averages. I want to just average everything out. I'm not looking to be super perfect, and this is how I've done it many times, and it's always worked. So I'm sure that this is just fine. So that's the average. We're going to work on the middle. So here's the middle line, and here's my water line. Take a pair of calipers. Pick up a pair of calipers. I'm looking through the camera, so things are kind of slightly hard, but that's okay. And let's say I'll measure this, okay? I'll just measure it like that to water line, yeah? Exactly in the middle. And I came out with 34 centimeters. I'm working in meters, so I divide everything by 100, and that's how I come out with, because I'm looking for cubic meters, which is a ton of water. Okay, so I've come out with 34 centimeters is at waterline, the width of the armor. At the bottom I've got 0.10, the bottom of the armor in the same area over here in the middle. This is 10 centimeters. Okay, good. So now the average is very simple. It's 0.34 plus 0.10 divided by 2. So it's this plus this divided by 2 gives you this, which is 0.22. Okay? So I got that's my average of that's to my water line, that's my average width, which will give me now the whole thing. Now, all I have to do is 0.22 times 25 times 0.25, because 25 is my water line. That's how much this armor draws over there. Come out with 0.25, and then times 2.7 meters. Why am I doing 2.7 meters? Because I'm just doing it straight from here all the way to here. Because like I said, they are identical, so I just might as well just go 2.7 meters, which is from here to here. Okay, and then I do that, and I come out with this figure, which in that's how many liters it will hold, which is 150 roughly, liters, which is equals to kilograms. So that's my volume, okay? That armor in these two center compartments will hold 150 liters to waterline. Good, let's continue working now. Now I've got the bows. The bows are a little bit more messy. So I've drawn a bow, yeah, and the bow's got it's got rocker, okay. Now rocker messes up life a little bit, so we're going to look for an average over here, for an average height of the draft, okay. We don't want to work on full draft, we don't want to work on minimum draft, we want to work on a center draft, and then we're coming out roughly good, okay. So we're looking for the average over here. So but first I want to explain that basically the two bows together, because if I take the one bow and the other bow, I cut it down the middle and I put it on here one and here one, I'm coming out with a triangle cylinder, whatever this thing's called now. So if I'm coming out with a triangle cylinder, I'm ready to go, it's a piece of cake, okay? But I still need my average waterline, which is over here somewhere, okay? So I got 10 centimeters over here of draft, and I've got 20 centimeters over here of draft. So that would give me a 0.15 of draft in the middle. It does mess up the triangle side slightly, but it's these mistakes on they're nothing. You can just neglect all these little mess ups. These mistakes they really don't matter. They are so minor that it's a 10% to here or to there. It just doesn't matter. So let's say that's the height of this triangle. I'm going to make it to a 0.15. Okay. So then I measure my armor at the top over here. Yeah. And I come out with 0.3. I do that again with the calibers. Okay. I'll measure exactly over here, exactly at the bulkhead, where the armor is the widest and at the waterline. And I came out with 0.3. So that's my cylinder. That's what it is. It's a 0.15 by a 0.3 by its length. Now the length, I'm going to use only the length of one bow. I'm going to do 1.4 meters, which is the length of only one bow, because the other bow I've cut it in half and I've put it onto the both sides of it. So basically I need width, depth, length, and I'm ready to go, and I've got the whole deal. So basically we're down to calculating now the cylinder. So 0.3, yeah, by the depth of it, which is 0.15. So I'll go over here, 0.3 by 0.15, and I'll divide it by 2, because I'm looking for the area of a triangle now, not a square anymore. And I come out with 0.0225. Now I'll take that figure and I'll times it by 1.4. 1.4 is the length of only one bow, because like I said, I'm taking another bow and I'm putting it onto here, so I'm not going to do the two bows, but I'm going to do only one of them, which is 1.4 meters. And I do that times 1.4 and I come out with 0.0315. So now that's liters, that's volume. Now, so that's 31.5 liters of volume on both my bows. Okay. And then we go on to this. So now the total volume at waterline would be 150 the two center compartments plus 30 the two bows, comes out to 180 liters of displacement at 25 draft. That's TNT. I'm really happy with that. That's perfect. Now I want to know every centimeter after that, how many kilos do I have to load this boat for every next centimeter after 25. Okay, so basically now it's 0.34 times 27, which is the full width. The full width over here for the two middle compartments is 34 at the top, because we're going now only up 1 centimeter at a time. So 0.34 times 2.7. Okay, so that's that one. And then the bow ones is, the two of them is 0.3, which is over here, the widest section at waterline, because we're going up, but only times 1.4 meters again, same deal. This times this times that, this plus this and that, divided by 100. Okay, you got to divide by 100 now, and then you come out with this. You come out with that and that divided by 100, and then I come out with 0.0138. So that's 13 liters per centimeter. That means that when you load this armor, it takes 13 kilos for every centimeter draft after waterline. Okay, now because there's quite a lot of flare on this armor, that 13, the first centimeter will be 13, the second centimeter will probably 14, 15, the next one will be probably 16, 17, I don't know. On Proas, you really have to know your volumes and stuff. You really have to be good on your waterline and stuff, because if you don't, then your Proa is going to float like this or like that. Okay, it's not a catamaran where, you know, it depends how, it's all the same, so it will always float like that, unless you've loaded it stupid and it will float like that. But on a Proa, if you're not smart, if you can't do the calculations of how high to make those guys, what's the span between the akka and the hull, yes, if you can't do that, if you can't calculate volumes, you can't come to that either. I find this way of boat design to be just simpler. Instead of drawing pictures that you can only imagine, this is going to work, it's not going to work, I don't know, this just seems like the easy way to go. You have a model, it's working, it's just showing you what's happening, you can see it. You can see it actually what it's doing, you know, and then you can come out with your numbers. You just measure now, you're not even thinking anymore, you just got to find a way to measure it and you keep going. Hi all, welcome to Balkan Shipyards. So here we go, we're starting to build HAVAYA 30, 25. That's her name because I shortened her from 30 foot to 25 foot so the Vaka can fit in here. 6.7 long material, poplar 8mm thick, 2 butt blocks connections, one here, one here. I've sketched out the bow. Basically I'm doing half the armor. So 1/4 of the armor is cut out, and now I'm tracing it onto that one, and then I'll flip it over, do the other one, and then I'll use that one to do the first one. Armor side panel, I've got the shear clamp glued on. I'm using polyurethane glue, and you have to work very fast over here, there's no time. So what I do is I take the batten and I pre-drilled all the holes, and then I screw it in, I don't know, every 20-30 centimeters, and I'm screwing it into the ply. The screws coming out the other side, and that way I get a quick clamp. And then after I'm finished running all my screws, then I put clamps in between the screws. I had to narrow the shear clamp at the ends so it climbs up. Here, this one is done already, did it yesterday. And then I take a knife and I cut the glue from the top, and then I chisel it off the plywood. Basically that's how the shear clamps are put in. And here's a scarf, long scarf done with epoxy. So I mounted the bottom. The bottom is the offcut of the shear. How I cut the shear, then that's the piece that's left over. I calculated for that. Basically what I did is I screwed on a temporary batten, just a few small screws as high as I can go. That's to stiffen up this side of the boat. Because what I'm going to do is, this is the failure side and it's got a nice curve to it. So I'm going to use this curve and copy it over. So I've done that, and then I've stiffened it up with the batten, and then I've screwed on this piece with a few little screws here and there into the batten, and this piece is fixed now to this. So now I'll go under the boat and I'll mark it from the inside, and then I'll use my offcut to copy over to the next side. So before that, what I did was I made sure that my piece of wood is exactly in the middle of the boat on both ends, and then I'm going to chalk line down there once it's flipped over, and the offcut will go over and do the other side. Bottom line. So it's freestyle boat building, you know, guys. I mean, you don't need a plan, you don't need too much. You can just make a piece of cardboard like this. If you can calculate volumes and stuff, and you know what shape you want to come to, once you got this, you can just go. Before filleting, I like to take a paintbrush with clear epoxy, yeah, and I like to paint the seams. And then when I get to a cable tie over here, then I go over like 60 times. And then what happens is the epoxy actually comes out through the holes on the other side, and it fills the whole hole. It seals up the hole, and then it comes out the other side, and therefore I'm getting I think that's good enough protection, and I don't take the cable ties out. So now I just got to finish this. Here you go. So now, I start at one end, I go to the other end, but what I do is I wet out, I fill it, and then I go back and I start putting down glass. This glass got black lines on the sides because that's how I draw it out with a felt pen, so I know where to cut with the scissors. It's not carbon, it's not nothing fancy, it's just junk glass. So like I say, I do all stages together, and then once I've glassed and I'm moving ahead with my filleting, then I'll take the next mix of clear epoxy and I will wet out the weave. I'll wet out and fill the weave. So basically I do all stages at once until I'm done. Check out this armor. This is the armor of the HAVAYA 30-25, and this is a 6.7 meter armor. There's make or break up on top of the cupboard, and 6.7 meter armor with a lot of volume, a little bit of a flat bottom in the middle for the dagger, and then a little bit of rocker. So it's all straight cuts. It's all straight cuts. No fancy cuts over here. A little bit of rocker, so it's rising up. And then I put in stems. This is a James Warham idea, and I really like these stems because basically it comes. I mean, it's coming to about here inside. So that's a lot of protection. So if I bang into something, I'll probably break this. I might even break to here, but I'm definitely not going to go in because the fillet comes all the way to here. So there's a lot of bow on this thing, eh? Let's wrap this thing up. It's about, I don't know, it's 2nd of March or something, or 3rd of March, and it's I don't know, 8 o'clock in the evening, and the fireplace is going, and we got to finish this build. This boat has to sail this year. So wish me luck, all the best, Balkan Shipyards. We keep going. HAVAYA 30-25.